Now let's get started. I would like to first welcome everyone to join our webinar. This is a series of webinars that we always do at Blackbird. We did a couple in the past, and now today we're going to talk about storing time series data in the cloud with Azure. Well, this is a topic that we like to do the most. This is one of the most requested application that we always develop for our clients. So now it's time for us to share how we built these, how we deliver this to our clients, and what kind of issues do we see, and how do we think it's a good platform is for a time series data in the cloud. Now let's just jump right in. Well, let's begin with an agenda of our talk today. We're going to start with a little bit of an introduction of who we are, who Blackbird Cloud is, and what our knowledge base will be will contain. And then we're going to get going with the time series data, what it is, the definitions, the characteristics that we see. We're going to continue on with the common issues and pitfalls that we see on the fields with time series database. And this is based on our experience. And we'll end off slowly with an efficient solution of what we think is a good solution for storing your time series data on the cloud. We'll end on a demo. I hope the demo works. I'll pray to the demo gods. So yeah, a little bit about us. We're a cloud management platform. We manage clouds for our customers. They started from medium company to just small startups, and it's a wide variety of type of company. I'm a computer. See, the picture is there in the middle. I'm gladly joined by three of my other colleagues, Yuri Malenberg, Tom Bogers, and Melvin. Four of us, we have a diverse background in software engineering and also cloud engineering. These are the values that we really built Blackbird upon. One of the important values that we want to have today, that I want to bring up today, is the expertise part. This is why we always do our knowledge sharing with everyone. We write blogs once a week, and we always do once a month a webinar about what we think is important and our tech findings and those kind of things. So enough about that. Let's just jump right in. Let's start with a little bit of a definition of what time series data is. This is something that I yanked out of Wikipedia. Time series data is a series of data points indexed in time orders. I think this is a good definition. The highlight here is the word index in time orders. I'll show a little bit of example why this is an important part in the next slide. Here, as you can see, this is a sample of a time series data. Again, it is indexed in time. As you can see here, this is a JSON blob, JSON array with time, value, and labels. The time is the index here, so every time there's an event, the timestamp is made. A certain value is added, and a label is added. It could be many different forms than this, right? So we're not only limited to this. So some of the characteristics that I'll touch up here is that, as you can see here, that the data is written in a high frequency. In this case, this is 1 per second. We see in some cases it's a millisecond level frequencies, and sometimes they even have different labels, different values, of course, and different monitors, and different ingested. As I've also wrote here, they can also have multiple streams, and this slightly amplifies the volume of these time series database. So what is a typical time series application, you might ask? It usually is an IoT device that sends out sensor reading informations like temperature, voltage, current for batteries, wind speed, you name it, right? It could be anything. Not only that the time series database or application can be in an IoT device, but it could also use for things like activity tracking, like user data tracking. Like if you have a website and you just want to see how the user flow or the user journey goes, like what button do they click, when do they click it, how often do they, not how often, when do they click it, and what do they go to next. And it could also be used for your data logger, like what I mentioned before. Most of it are data loggers. And audit trail is one of the most interesting use case for time series data. Basically, you trace what are the calls that goes to your API or your cloud providers. I think even Amazon does this with their CloudTrail. Now, These are the most common issues that we see, right? So those high frequency data writes, they tend to clog up an ingress. So if you just have an ingress, which is just an HTTP API, sometimes you just have these overheads that comes in. And if you have a high frequency of HTTP calls, yeah, those overheads can tend to accumulate and sort of burn your servers, like how it's visualized here. The index size I want to bring up is also a common time series issue because, well, you have a lot of time information coming in, right? So you have time and value and labels, and your index might be a third of the size of your database, which is unhandy. And also, especially if you're doing queries, then you don't want to scan everything because it's going to take a while and it's going to make your query performance really bad, and that's something that you just don't want. Next to these are the asymmetrical load between reads and writes, right? So data will come in nonetheless. It could be every second, every millisecond, every minute, every hour. It will constantly come in, but the writes, they tend to become, well, not really symmetrical with the load of the reads, right? So imagine if you have a monolith service which handles both the read and the write of your data, right? As in, like the devices or any of these data source, they keep on pushing the data to your service, to your monolith, and then you have clients like dashboards, third-party APIs, user querying your database, and all those sort of stuff that queries your monolith. Then it tends to affect one another. So if you have a lot of writes that will block up the whole, clog up the whole resources, then your client's read performance will also be affected. So that's something that you don't want. Next to these issues, we also have compounding storage costs. I want to highlight this a little bit further because this is some of the most important issues that we see a lot in time series data. I have here a small visualization or some small indication of how the problem can be formed. Here I have an example of two costs, right? A fast tier cost and a slow tier cost. These are just storage costs per gigabytes. Fast tier means that you could get your data fast, as in millisecond, sub-millisecond level. Slow tier, it could be in the range of 1 second duration. These are just taken from S3 cost. This is a simple number crunching. And here we have storage sizes. As you can see, the storage sizes here increases by 100 gigabytes a month. That's the nature of your time series database. Usually that accumulates everything up until, for example, if you have some retention rate, but I'm not going to go into detail with that for now. Most of the use case, they want to keep everything for the sake of analytics in the futures, or getting a year worth of information to get a better understanding of how a trend progresses, or in IoT scenarios, how a component behaves over time and those kind of things. Here I have just a cost without optimization. These are just storing everything on a fast tier. So imagine if you have S3 buckets, store everything on an S3 buckets, and then the cost will slowly rise up, and it will rise faster and faster with the more data, or I mean, it will go higher and higher with the more data that you store there. Here it's visualized on the blue line on the charts. As you can see, well, it's quite steep. It doubles in a year, and yeah, it will go even faster. Well, this is a simple simulation with just 100 gigabytes, and it could be that your scale might be way larger, and the increase might be more, and you might get more customers, that the increase is going to be faster, and those kind of things. And then on the next column, I have cost with optimization. So this is just a simple optimization where we put 30% of the data in a fast tier and 70% of the data in the slow tier. Why, you might ask, why you want to do that? Because we think that, based on our experience, most of the data that are relevant for the user in terms of fast performance are the really recent data, right? So that's why we always put some sort of a time boundaries on where we put the data. So recent data or fresh data, we keep it on the fast tier, and then like old data, we put it on the slow tier. In that way, they both are still accessible, but it's just a little bit more cost efficient. As you can see here, the cost saving between these two, the cost optimized and without optimization, they also increase over time, right? So just by doing these simple 30/70 splits of your data, you already save some money, right? And the slope of the increase of the cost, it's slightly lower. Then like you can manage the cost slightly better, right? So you could tweak these based on your needs, right? So you could say, okay, I want to add a retention rate of 1 year because after 1 year it's not important, or maybe I want to reduce the data frequency not only by millisecond, but I want to make once every minute or something like that. Take a sample of it. That could be a thing, and so on and so forth. So based on that issues that we had before, and also the compounding costs, we were thinking of what should be the efficient solution, right? So we're brainstorming a little bit, and then we come up with these characteristics, right? So first of all, it should have a stable cost over time, right? So your cost shouldn't increase more and more and accumulate over time. You want to be able to sort of like put a plateau, well, not a plateau, but lower down the cost every month by the more data that you put in, right? So you have a couple of strategies to do that. You want to make sure that your system is fault tolerant, right? So like what I mentioned before, if you have a write and a read process in the same time in one monolith, then if one is overloaded, you're going to demolish the other, where the other is going to have some bad time, and that's not good. So you want to be able to split those up. Good query performance is also one thing, because we see a lot of these data lake or data storage solutions out there. They tend to have okay-ish performance, but they don't have some second performance. So if you're doing data analytics on like your data pipeline, that's fine if you're under if you're over like 30 seconds or to 1 hour. But if you're doing dashboard delivery to your customers, then yeah, you might want to have a good query performance there, because it's quite directly coupled. Next thing to good query performance is to, maybe it's nice to be able to do real-time analytics or data enhancements on your stream, right? So if you have, let's say, a battery, and a battery will shoot in voltage and currents, and you want to get the power out of it, so you make a small data analytics app that will combine these two values, the power, the voltage and the current, and generate power. Right? And then you could do that, so on and so forth, for like energy, and that you could take like, okay, energy used per day or those kind of things. So based on that idea, we came up with this sort of architecture. This is something that we always do well, sort of looks the same for all of our customers. The architecture that we always come up with is that we always have, well, on the left side, that usually is something that's out of our control. Those are the data sources, those purple boxes. They could be a third-party API or a device that the company or a customer have on the field that sends off these information. Could be anything. What's important is on the right side, we will start with the event hub. Event hub is basically just where all these data points get pushed to, right? So these are your ingresses. What the event hub does, not only that it takes the data, but it also parks it for you, right? So imagine as a log, a continuously moving log. It will keep that for a certain period of time so that other processes can read, right? So in this example, I have a data processor that will read the data from the event hub, but it could also push it back, right? So the same as what I mentioned before. When you're doing real-time analytics, you could generate more data from your existing data on real time. And then it could also be read by a data offloader. What a data offloader does is that it will take the data from Event Hub, and then it will just push it on a more efficient storage. It will do some data manipulation, as in like a reconfiguration of the data, making it into a file, and those kind of things. I'll go into detail on each of these components after this. And then you have the blob storage. Blob storage is just a super efficient storage, things like S3 or Azure, what is it again? Storage account or storage container, or blob storage, they call it. And then we have the query engine, right? So the query engine is the interface between the clients and the data, right? So data could come from the blob storage, where it's long-term. You always have the data there. or it could be a real-time information that comes in from the event hub. And that will be served to the client. Right? So you should be transparent from the client side. So going into detail, what is these components are? The event hub here in this case, like what I said before, it's just a log. It keeps the day. Right? It should have a short retention time, whether it's days, weeks, hours. It depends on the scale that you have. Right? So the longer you keep it, the more that you're kind of secure, let's say, in terms of, let's say, if you're doing database maintenance or if you're doing some major data migrations, then you want to be able to kind of keep those data in without losing anything, right? So if you keep it for 1 hour, and let's say you're doing a database migration maintenance for like 5 minutes, then your reading processes or the offloader can just stop for that point, do the database migration, and then continue where it left off. And in that way, then you don't lose any data. Basically, it's a buffer system. So tools that are out there are Kafka, Azure Event Hub, and Amazon Kinesis. There's multiple options that you can pick for this one. Next to these are the data processor. The data processor takes data from the Event Hub, reprocess it, and then re-emit it back. It's quite simple, straightforward. You could use things like an AWS Lambda or an Azure Stream Analytics for this, or you could write your own custom application that takes metadata from your database. You can be free with this. Basically, what a data processor does is that it creates an independent processes that will create some sort of a data pipeline for yourself, right? So you take the raw data, you refine it, and then you put it back, and then you could have another piece of data processor that takes those data, combine it with something else, and then put it back. So you can keep your application quite small in that way. Next to these are quite important as well, the data offloader. What the data offloader does, it is almost exactly as the same as the one before. The difference is that data offloader takes those data, format it in a way that's just quite efficient to be queried later on, and it just puts it on the blob storage. Right? So the format of the data, it could be, let's say if you have a JSON incoming like what I had before, you could turn that data into a CSV file per hour or per K. Right? We tend to use per K because it's quite space efficient. It's binary. It's not text-based like CSV, but it also has its own downside because it's not readily available and it's not easy to take data out from there if you don't have any of these systems. And one other thing that's also important is for the data offloader is how they put it to the blob storage, right? So it needs to be able to, the data query needs to be able to find the file that needs quickly, right? So one thing that we always suggest is to have it on a high format. I'll show it later on the demo, how this will look like. But essentially, it's basically an indexing of the files based on your file path, right? So you can have, let's say, a device equal 1 and slash year 2024 slash month slash date, and then you get the file itself, right? And that way, then you could the query engine will just traverse through those files, and it already knows, oh, if I'm looking for this device, this date, then I know which files to look at. Some of the tools out there are AWS Kinesis, Firehose, or you can just write your own, same as the data processor. I think Azure have Stream Analytics, but it have some sort of a helper to build this for you. And on Firehose, it just works as is. So it's simple. Next to these are blob storage. It's simple. It's that simple. It just stores your files, the CSV files that the offloader made. It needs to have a cost-efficient aspect on it, of course. Most of these systems out there have some sort of a tiered storage that will save cost a little bit by sacrificing your access performance, right? And they also have an automatic object lifecycle between tiers. So if you put it on the fast tier, then you can configure some sort of a lifecycle that will move it to a slower tier over time automatically, so you don't have to write your own application to move from one tier to another. Tools that can be used for this are S3 and blob storage. Super easy, super quick. You can just deploy it in an instance. last but not least is the query engine itself. The query engine, what it does is it just queries data from blob storage. Uh, it can also query data from Event Hub if you want, right? So if you have some sort of a real-time dashboard for your customer where you want to see like, oh, I want to get like the last 2 minutes worth of data, for example, because you just want to push that to your front end and they just have a continuously moving graph and those kind of things, you can query it from the Event Hub. It acts as an interface between client and the data itself on the blob storage, right? So you can, of course, write your own query engine, but we would advise not to because these tools, they are perfectly able to handle those easily. They create some sort of a SQL interface or SQL-like. Azure Data Explorer, for example, they use custom query language as an interface so that you can just query your data seamlessly of what you have on the backend, right? So whether it's from blob storage or it's from a third-party API or it's from the Event Hub itself. So don't try it yourself. Use something that's already out there. That's what we always suggest. Now, on to a little bit of a demo. I'm going to show how it all looks like in Azure. I have a small script here that I'm going to share in a moment. Oh. So I have here a small application that connects. It's a Node.js application that connects to an Event Hub. It uses a native or just Kafka.js client. It has some sort of a Kafka endpoint that you spoke to. And it produces every second an information here. And on that, every time it produces, it says what the topic is. The topic is raw data. And then we have multiple messages that comes in. Here it's keyed on monitor one, or on the name of the device itself. In this case, is monitor one. It has a time, just take now, some random data, and a few labels: temperature, pressure, and which device it is, right? So monitor one in this case, or monitor two. It continuously produces this, as you can see here, over time, every seconds, and it will all end up in Event Hub, right? So this is how it looks like on an Event Hub. Basically, this is a Kafka cluster or just your Event Hub cluster. It receives 200 messages. I think this is every minute or something like that, because we have a bulk of messages that we send every second. And then it just parks it. Here we could see, I think, also how we keep it. 1 second, how long we keep it or how long we retain this. It should be here somewhere. Oh, no, not there. Here, this is the topic that we created, right? So it's raw data, and inside this topic, well, you should be able to see the same thing again because we're only pushing for one. You could have multiple of these streams, raw data, analyzed, you name it. Here, I think on the configurations, we should be able to see how long it's retained, right? So in this case, it retains the data for 168 hours, which is 7 days. Basically, if, let's say I'm doing a database maintenance, I have 7 days to finish it, which is plenty of time to do a database maintenance. Or if I'm doing a migration, could also be the case, right? In that way, then I have another app here that's called Stream Analytics. And what this will do is that it will just offload it from the Event Hub data, and then it will push it to storage accounts. Doesn't do much. There's a helper to build this, so you don't even have to write it yourself. And I'm gonna go directly to the storage account because that's more interesting. So here I have one storage account with a one container. That's right now, I think it's called raw data. And here, as you can see, this is what I mentioned before. This is how we keep the files, right? So the files are structured in this way, where we have device name, monitor one, and monitor two. So in monitor one, we have the year, we have the month, we have the day. I've run this for 3 days now. And then on these days, we have all the files. So these contain all the files that or the data that we sent from that Node.js app. right? And in this way, whenever we're querying for this specific day, then it already knows how to traverse, right? So it doesn't have to scan one giant file because scanning files are expensive. And so how do we query this is through Data Explorer, right? So I have a Data Explorer cluster. Basically, it's just a cluster to help me query all these database. Let me just go to one of these. So I have a database, I call it raw data as well. And here I can do my own query. So this might take a little bit long. Okay, Azure, don't fail me now. Yes. So here I have an external table, and I call it the raw data table, external table. So what this external table does is I tell the Data Explorer cluster to say like, hey, there's an external table. Well, essentially, I don't have the data with you right now on the Data Explorer cluster, but the data is available on the storage accounts. And then you can configure where the storage account is and how the index looks like. So here, for example, I have an external table with all the columns that I sent, right? So time, data, label, device, event processed, date, and also when it was enqueued and when it was taken out, and the partition ID. So here I could do a query, things like, okay, run a query for get monitor 2. I will happily run it. Here it already knows, okay, I'm gonna query everything for monitor 2, already knows how to find the files, and it will just happily show you in a table format. Simple as that. So you query for more things here, okay, just do monitor 1, for example, and instead of limit, you can do limit 5. You can do your typical SQL query here, and you don't have to write the code yourself where it looks up on the blob storage for like the files, and it will scan and those kind of things. And they already built this. On S3, I believe this is called S3 Select or Athena if you want to scan multiple files. And they provide the same interface, basically, and you can just have it right there. So this is, in essence, how we build a time series database. I'm going to go shortly to the presentation again. Yeah, that's it. Anybody have any questions? Feel free to add it on the comments or on the chats. I'm glad to answer that. Gonna take a minute. I think it's quite quiet, so I think I'm gonna end it right now then. So yeah, thanks everyone for attending this webinar, and I hope I can see you again in the next one.